Hello, my name is Bharath Reddy. I'm a product manager in the Exalogic group. I've been with the product since inception, and I've been with Oracle for about 10 years. So today I would like to talk to you about business continuity, the importance of business continuity in enterprise, especially DR, which is disaster recovery. I want to cover the concepts of disaster recovery, Oracle's strategy for disaster recovery, how Exalogic fits into that strategy, and what are some of the best practices that you need to use while setting up a DR site, the various DR topologies that are possible today, and several other things. So with that, there's lots of material to cover. Let's jump into the slides. So this is the agenda, an overview. So let's look at what business continuity is all about, right? So when we ship Exalogic is built with all redundant components, and that's basically how we sell it to you, saying it's a completely HA machine. But even in spite of being a completely HA machine, the machine cannot protect against certain issues like multiple failures, corruption, accidental user deletion. You could have Exalogic system failure due to a site outage or a disaster of some sort, or loss of power, whatever it is. So Exalogic, even being an HA system, cannot protect against this. So that's where business continuity comes into play. That basically what it means is it is running your business, all your key critical mission critical applications. In order to have this, you need proper backups so you can restore. So that's where the backup and recovery, that's covered in a different session. We've covered that. So this session we'll talk about disaster recovery. So this is where we basically need a proper plan for DR. Let's look at some of the disaster recovery terminology we use. What do we mean by primary site? What's a standby site, a symmetric site, an asymmetric site? The switchover, switchback, the failover, failback, what the differences are, the various kinds of replication, what RTO is, what RPO is. So primary site is typically the site where your production environment is running. That's the primary site. Your standby site is your standby site where it's a passive site, or you're running QA, or it could be it could be another active site where you have active deployments. It just depends. So that's just basically your secondary site, your second data center. Then you have symmetric sites. What is a symmetric site? When you have one-to-one match of every single component, that's a symmetric site. All the components are matched one-to-one, including the apps, how they're deployed. Asymmetric site is where you don't have a one-to-one match. So you could have, for example, you could have a full rack Exalogic on one side and a half rack Exalogic on the other side, and that's a asymmetric site. Even if the apps are deployed incorrect in a different form, if they're deployed non-HA on the standby site and on the production site, if they're deployed HA, then that becomes an asymmetric site. Asymmetric site is one where the components don't match one-to-one. Site instantiation is when you actually instantiate your standby site. You're bringing up, you're pushing the configuration, you're pushing your data from the primary site to the standby site. That's what site instantiation is. Site synchronization is synchronizing both the sites. This happens with replication and data guard on a regular basis. So that's what site synchronization is. Switchover and switchback, and failover and failback. A lot of people use these terminologies, use these terms, and they just mix and match. So they think it's basically switchover and failover are the same. They're not. So what is switchover? Switchover is when you move your production site from your primary to standby. So now your standby becomes the new production, and your original primary becomes the standby. So switchover is a planned event. For example, if you're doing maintenance on your and if you want to do apply patches, so you would switch over to your DR site, patch your production site, and then switch back. Switch back is reverting the roles from reverting the roles to their original form. That's what a switchback is, and again, it's a planned event. Failover and failback. Failover is when your primary site goes away, and then you fail over to your DR site. Failback is when you rebuild your primary site when it comes back up, and then you reestablish the roles correctly. So that's when a failback happens. Asynchronous replication is when you're replicating storage, you write a block to the primary storage, and then that block is the commit is issued, and then that block is shipped over to the standby site. So that's what asynchronous is. It's like basically there's a lag. The lag is dependent upon the network latency. Synchronous replication, what we mean by this is you write to the primary storage, and then that block is shipped to the standby storage and then and that's when and it's written to the standby storage, and that's when the commit happens. So that's synchronous. So you have to write to both sites for a synchronous replication. Recovery time objective and recovery point objective. So two important things: RTO, RPO. So that's the short for abbreviated term. The abbreviations for those. The recovery time objective means how long can you be down. Recovery point objective simply means how much data loss you can incur. You must define these two key parameters because these two key parameters will drive your backup frequency, your replication frequency, so on and so forth, and are tied to your SLAs. So let's look at some of the key considerations for DR. You have the Exalogic components. You look at what infrastructure components you have, what artifacts. Basically all the artifacts should be stored on the storage appliance. You have to look at, you have to categorize your data, whether it be volatile data, semi-volatile, or non-volatile. So what we mean by this is data that changes frequently is we categorize it as volatile data, like JMS logs, JMS, T-logs, log files. Semi-volatile is configuration data, non-volatile binaries. They change on a very rare basis because this again defines your defines how various shares are replicated and what replication mechanism to use. You have to look at what kind of DR topology you want, whether it's a symmetric or asymmetric or active-active or cross-replicated. By that I mean you run part of your applications on site 1, part of your applications on site 2, and they cross over for DR for each other. Lots of customers want complete utilization of hardware, which is understandable. So you can do active-active, or you could do your active standby with the standby being used for QA. There's several options. So these are some of the key considerations for DR. Now, additional key considerations you need to keep in mind is capacity planning, because if you want the same level of capacity on your standby site, that means you need to plan for that. You just can't expect to buy a smaller machine on the standby site and say, I need the exact capacity and the performance. So service level agreements, you need to define your RPO, your RTO, because this is what drives the replication frequency. These key considerations are important. So all this comes into play when you're designing a DR site. All right. So let's look at some of the typical needs, right? You have typically customers either want an active-active data center or an active-passive data center. What this means is, the primary data center runs the apps during normal operations, and the secondary data center is in standby mode to take over in case the primary fails. The database is also active-passive. Customers typically expect, whether it be a symmetric or asymmetric, they expect complete utilization of hardware. The other thing they expect is minimal data loss. So they need the recent copy of the data that on the secondary site. They need the data to be consistent. And then for active-active data centers, this is one topology where a customer wants to have the application running on both, and transactions are happening on both sides. But one thing to keep in mind is if there's any external entities that are needed by the application, if they're not active-active they're not in an active-active configuration, then your whole active-active story goes out. Doesn't make any sense. If you want a true active-active, all the touch points for your applications need to be active-active. So keep that in mind. Again, this could be a symmetric topology or a symmetric topology. Again, hardware utilization is completely utilized in this case. So Oracle's approach is pretty straightforward. It's the middle tier. The app tier is native storage replication. You deploy all the applications on a shared storage device, and then you use the native storage replication to replicate the configuration, the binaries, any other extra files like log files, etc. For database, it's basically Oracle Data Guard or Active Data Guard or Golden Gate. Depends on your use case. So for Exalogic Exadata, because ZFS is a storage, it's a shared storage in Exalogic, we would use ZFS replication for the middle tier for all the for Exalogic. So basically, ZFS replication is how we do DR for Exalogic, and Oracle Exadata, again, Oracle Data Guard, Active Data Guard, Golden Gate, etc. So this is Oracle's strategy. If you look at the diagram over there, basically shows you an Exalogic with Exadata and the ZFS replication happening between the two storages, and then Data Guard happening between the two Exadata databases. Built in. What I mean by this is the ZFS storage that comes with Exalogic has DR support. We use replication, ZFS replication for to replicate contents of one ZFS to another ZFS, and that's what we use for DR. So you get replication, you get DR support for free. So there's no additional licensing for replication. It comes with the machine. So on the application tier, some of the considerations, you need to make sure that all the artifacts on the ZFS. And one thing, ZFS replication will work with Exalogic without any modification. There's 3 types of replication types we have that can be used: continuous, scheduled, and manual. We'll talk about them in one of the next slides here. Exalogic DR will work in tandem with Exadata DR. So with Exadata DR, you can figure out whether you want synchronous or asynchronous replication, and then you have data guard, active data guard, and golden gate. So there's all these things. So these are some considerations, and let's look at some of the best practices for disaster recovery. So make sure, from a disaster recovery standpoint, you need to make sure that the primary site and the standby site, they're on separate IB fabrics. This is very common sense, right? So in case there's an IB, if you have both your standby site and your primary site on the same fabric, in case the fabric fails, you've lost both your sites. Make sure to do regular switchover, switchback. So the problem here is people define a DR procedure, but they never test it. So when they go to do built in. What I mean by this is the ZFS storage that comes with Exalogic has DR support. We use replication, ZFS replication for to replicate contents of one ZFS to another ZFS, and that's what we use for DR. So you get replication, you get DR support for free. So there's no additional licensing for replication. It comes with the machine. So on the application tier, some of the considerations, you need to make sure that all the artifacts on the ZFS. And one thing, ZFS replication will work with Exalogic without any modification. There's 3 types of replication types we have that can be used: continuous, scheduled, and manual. We'll talk about them in one of the next slides here. Exalogic DR will work in tandem with Exadata DR. So with Exadata DR, you can figure out whether you want synchronous or asynchronous replication, and then you have data guard, active data guard, and golden gate. So there's all these things. So these are some considerations, and let's look at some of the best practices for disaster recovery. So make sure, from a disaster recovery standpoint, you need to make sure that the primary site and the standby site, they're on separate IB fabrics. This is very common sense, right? So in case there's an IB, if you have both your standby site and your primary site on the same fabric, in case the fabric fails, you've lost both your sites. Make sure to do regular switchover, switchback. So let's look at some of the Exalogic topologies. So we have a symmetrical topology and an asymmetrical topology. Well, a symmetrical topology is where you have, or a symmetric site is where you have both the sites are identical in all respects: machine size, software, applications, anything. It's a one-to-one match. So typically, a lot of customers prefer this, where they want a symmetric topology, but sometimes the cost associated with this is high. So people, they go, this is what they typically prefer and mostly want, but the cost is a factor that deters them. For the middle tier, we use storage replication and the storage replication uses a dedicated gigabit DR network. We'll talk about the DR network in the network topology slide for DR. Asymmetrical topology, so the systems are not identical in more than one way, or one or more ways, basically. You could have the same machine size but different applications. This is what is typically implemented, because you have a larger system running production and a smaller system running DR. So again, the replication is ZFS. The storage replication again uses the gigabit DR network. Let's look at the Exalogic network topology in context of disaster recovery. So if you look at an Exalogic machine, you have compute nodes, you have the gateway switches, the storage system, then you have the management switches, or the management switch, and the spine switch. So all the components are interconnected to each other over the InfiniBand backplane. So now if you look at what the 10 gigabit interfaces are on the IB gateway switches, they're used for ingress and egress traffic to and from the data center. Then on the management switch, we use the management switch for managing all the physical components. And the storage system, basically on both the heads of the ZFS, you have 2 additional ports. These 2 additional 1 gigabit network ports are used to configure the replication channel. That's what you have the DR link A and DR link B. DR link B is basically the redundant link, but when you configure the replication channel, you get one replication channel between site 1 and site 2. And the exact steps to configure this are in the backup and recovery white paper as well as in the DR white paper. So because this is the same channel that's used for doing backup and recovery as well. So that's the overview of the Exalogic network topology in context of DR. Now let's look at the storage topology. So within each rack, you have all the hard drives that are mirrored, and then you have within the storage itself, all the hard drives are as a part of the single pool. And now again, this is what I was talking about in my previous slide, that there's two additional ports on each side. So you have net 1 and net 2, and then you have on the primary head and then on the standby head. So basically, you would configure them to create the replication channel. Let's look at how replication happens. Replication basically, you create a snapshot of a project or a share, and then they're copied to the DR side block by block. So there's 3 kinds of replication that are available with Exalogic. One is what we call scheduled replication. The other one is on-demand replication, and the last one is continuous replication. Let's look at the various differences. Scheduled replication is you create a schedule on which replication happens. So for example, you would say, I want my WebLogic 1 backup share to be replicated on every day at 10 a.m. So that's a scheduled replication. On-demand replication is when you want to do it right now. It's a manual method. Continuous replication is used to continuously replicate 2 shares. So you would use continuous replication for JMS messages, T-logs, so on and so forth. So that's what we have. That's from a replication standpoint. Now let's look at some of the considerations you have to take into account when you start setting up DR. So one is you need to make sure you have your service level agreements. Your RPO is defined, your RTO is defined. This is what drives the replication type. Basically, if you don't have this, you do not know the replication frequency. How frequently do you have to replicate? You do not know, how many times a day you have to replicate, or whether you only replicate once a week. You have to figure out what kind of data you have, whether it's volatile data, whether you have non-volatile data or semi-volatile data. So it's basically data that changes a lot is volatile data, like JMS logs, JMS messages, T-logs, log files. Then you have the configuration data is what is semi-volatile data. And non-volatile data is like binaries. You don't change them on a daily basis. So that's what you have to make sure that you have taken into account how the various data types you have and put them in individual shares. Then you have to figure out what replication type based on the data type. So for volatile data, I would use continuous replication, and for semi-volatile, I would use scheduled replication, and for semi-volatile and non-volatile, I would use scheduled replication. And the on-demand is every time you make a maintenance change, I would do an on-demand replication, so I would do it manually. One thing is when you are doing replication, make sure you either do it at the project level or at the share level. So you can't mix and match. So that's one important thing. Let's look at Oracle SiteGuard. Oracle SiteGuard is our solution for automating DR operations. So with Oracle SiteGuard, we provide end-to-end DR automation. With Oracle SiteGuard, you get the coordinated failover of the middleware with Oracle databases, engineered systems. And Oracle SiteGuard is extensible so that you can integrate it with third-party systems. Like if you have third-party monitoring tools, you can use SiteGuard and integrate SiteGuard within that. So when we first designed Oracle SiteGuard, it was platform agnostic. So it did not care what storage you were doing it. You were doing what storage your applications were deployed on, or what hardware your applications was deployed on. But as when we came out with engineered systems, we pre-integrated Oracle SiteGuard with our engineered systems. So with this, you get you achieve graceful role transitions between sites. You reduce the possibility of human error. Basically at the end of the day, you streamline all your operations, your applications are recovered properly. So, and you define your sites once, and all your operations are, and you automate all your operations. So it gives you, it gets rid of this whole DR checklist concept, and all integrated into Oracle Sideguard. Let's look at how we automate DR operations with Oracle Sideguard. So Oracle Sideguard helps you automate your switchover, failover, failback, and it's pre-integrated with Oracle Data Guard for, it's pre-integrated with Oracle Data Guard for the database side. It's pre-integrated with ZFS. It's the way it's available is it's shipped as a part of the FMW management pack. It's available as an EMCC or Enterprise Manager Cloud Control management pack. That's how it's basically licensed as a part of WebLogic management pack or the database lifecycle management pack. It has out-of-the-box support for database, for both traditional systems, traditional as in commodity systems as well as engineered systems. Fusion apps and Fusion, it's pre-integrated with Fusion apps, Fusion middleware, Oracle database. So how do we achieve automation? So if you look at the diagram, we have we have site 1 and we have site 2. So typically when you go through a DR operation, you would create a DR checklist, and then you would go tick off each step or each number in the checklist as you proceed through your site failover. So with Sideguard, what you do is you take that checklist and you put it within Sideguard, and Sideguard will automate all of that. Like for example, when you want to make sure that your standby site, all the networking is available, you typically would go and run a manual command as a part of your DR checklist. You automate, you bring that into Sideguard and it automates it. So with Sideguard, what happens is you set up your site, you define your sites. So you bring up EM, you go to the Sideguard page, and you basically define your primary site and your standby site, and then you define your applications. And once your applications are defined, and it asks you for where your storage is and what type of storage and the shares. If it's ZFS and it's Exalogic, there's a whole bunch of automation that it brings on board, because it's pre-integrated. We know exactly what shares are used and how to do switchover, switchbacks, failover, and failbacks. So once you set up your sites, you instantiate your standby site, and then you use Sideguard to do the switchover operation. As a part of the switchover operation, you can a role transition operation. You can basically define a bunch of prescripts and postscripts that will validate, that are customized for your environment. And once that's done, Sideguard will go through and it'll run all the prescripts, then it'll run the switchover operation and the postscripts, and then bring up the standby site. So that's how we achieve automation. This is a blueprint, a general blueprint, where you see you have a web tier, an app tier, a database tier. So basically there's lots of things that need to be replicated between the sites. This is a typical enterprise deployment. So just wanted to show you the complexity of DR when you have large scale systems. So some of the operations, site configuration, that was the thing I talked about originally. Defining the site is what site configuration means. Start site is basically you start all the components in the site in a correct order. Like there's dependencies between the middle tier and the database. The database must be started first, and then the application server. When you shut down a site, the stop site functionality, you need to stop all the components in the right order. So these, then you have switchover, failover. We've talked about this. Switchover is a planned operation, typically done it's a planned thing that happens when you want to do maintenance on the primary site. You basically reverse the role of your primary and your standby. Your standby becomes your new primary, and your primary becomes your new standby. So you reverse the role. That's what switchover is. It's a planned operation. Then you have failover. Failover is you fail over to your standby site when your primary site is no longer available. So as a part of this, you basically Sideguard converts your existing standby to a primary. So benefits of Oracle Sideguard. There's lots of benefits that we have from Oracle Sideguard. So you basically develop the procedure once and you repeat it multiple times. So at the end of the day, you get rid of this the checklist you have, the DR checklist. The DR operations become more simple, more reliable. You can test it multiple times, avoid the issues that we traditionally see in DR. You reduce human error. So there's lots of things that can go wrong. All of this is automated. Then you minimize MTTR, which is the minimum time to recover. You basically reduce the human errors and the application replication. So typically in a DR operation, you would need an application expert, a replication expert, an infrastructure expert. All of these guys sit on site. But once with Oracle Sideguard, you don't need all of these guys. They can be available on a per need basis. So these are some of the benefits for Oracle Sideguard. And basically at the end of the day, you have increased confidence, and we handle the entire switchover failover as quickly as possible. For example, we've done some benchmarks. One of the benchmarks is human capital management running on Oracle Public Cloud. It took 45 minutes for us to do an entire switchover. So typically that would take in the magnitude of tens of hours. So, and you can also have with your prescripts and postscripts, you can integrate your third-party components like your load balancers and other stuff, and have Sideguard manage to do the DR operations for them as well. So now let's look at some of the key differentiators for Oracle Sideguard, right? So you have pre-checks and you have scheduled comprehensive health checks that are available. So basically this is available through your pre and post scripts. You have centralized logging, you have restartable options. What we mean by this is you can rerun some of the commands if due to a failure. So typically when you're doing switchover operations, there are some operations that you cannot rerun, but with Sideguard you can rerun some of these operations safely without causing any other issues. There's error management, there's HA support for all critical infrastructure like the database, the ZFS. Then you can also execute parallelly. So you can, basically that means you can scale across large deployments. Like Oracle Public Cloud uses Oracle Sideguard and they do parallel executions. Extensibility, you can extend Sideguard for your own purposes. Auto discovery of the topology change handling. So what this means is when you install Sideguard, it automatically discovers the topology you have on the primary site, and so you don't need to go create the whole site creation stuff. You don't need to go through those screens. It auto discovers a topology. Topology changes. So with Sideguard automatically discovers your topology. Not only it does that, it also will handle topology changes. So basically, if you scale up or scale down, Sideguard knows that the topology is changing and updates itself, updates the topology within EM, and then it actually looks at the credentials that are available in EM. And does you don't need to specify additional credentials for Sideguard. It just uses EM's credential management system. So with that, these are some of the key differentiators, and this kind of brings us to an end. So I have some references here for DR white papers and automation of DR using Sideguard. There's a really good white paper. There's of course the Oracle Disaster Recovery Guide for Fusion Middleware. So these are some of the key references. And here's my contact if you have any questions. And again, thank you for watching this presentation. I hope I was able to provide an overview of Exalogic DR, DR in general, Oracle strategy, and Exalogic DR in particular, and the various reference topologies. Thank you for watching this presentation. Overall, I hope I've provided you an overview of DR in general. Hope to see you sometime in another presentation. Thank you very much.